So let's do this example. They're asking us to determine the absolute configuration of this particular stereoisomer of 2-chlorobutane. And this is a Fisher projection. By absolute configuration, we mean is it R or S? And so the first thing we need to do is prioritize the groups. So we need to identify, we have 4 different groups here, and remember we go with the highest atomic number first. And so chlorine, I didn't mean to do that. Chlorine is the atom with the highest atomic number. We're comparing chlorine, carbon, carbon, and hydrogen. Now it kind of looks like this is bonded to the hydrogen, but we know that that can't be the case because hydrogen is always on the outside. So the chlorine is going to be number 1. And then we've got these 2 groups that start with carbon, and so they're the same. So we have to look at the next atom. Here is carbon, the next atom, and this one would be a hydrogen. And so this guy loses. This would be higher priority. Basically, the idea is the larger group has higher priority. The bigger person, the bigger entity has its way because it's bigger and stronger, if that helps you remember. And hydrogen's always going to be the little guy. And so he's going to be number 4. And then we determine the sequence of the highest groups. It's helpful if this lowest group is behind. So if it's either in the up position or the down position, that means that that hydrogen is going behind the screen. And then we're looking at, are these 1, 2, and 3, is this in a clockwise position to the right? My right hand would go from number 1 to number 2 to number 3. That's an R. So when we look at, if we put the lowest priority group in the bottom position or the top where it's behind the screen, then we can look at the order in which the others go. Here is going clockwise to the right. And so this has an R configuration. If the lowest priority group is on a horizontal arm, it's harder to look at. And so what you can do then is you can rotate 3 of the 4 groups to put that lowest group on a vertical arm. So if it's drawn this way, and here's the low priority group coming out at us, that's a dangerous way to look at it, because then if you look at 1, 2, 3, you're going to say, oh, that's S because it's going around to the left. But you're actually looking at it from the wrong side. And so if we take these guys and swivel them around, I meant to bring my model kit and I forgot it. But remember, there's rotation around a single bond, right? So we're going to hold one of these steady, and we're just going to twist this one. And so we're just twisting this around so the 1 comes up to the top, and then the 3 goes down here, and the 4 moves over here. Do you see what happened there? No?
If the hydrogen is right next to the 1, how's it at the bottom now?
Because it's a single bond.
There's a single bond. This is a 3-dimensional thing. Let me go get my model kit real quick. So then when we rotate that, now this is behind, and so we can look at these and see that it's going to the right. It's actually the R configuration. So this is important. Exchanging any 2 groups will give the enantiomer. You're not just changing the angle that you're looking at the molecule, you're actually changing the molecule. So if I want to draw, this was the R enantiomer. If I want the S enantiomer, I just need to switch 2 of them. In fact, let's do that. I'm just going to draw it over here. So let's keep the H at the bottom, just to make things easier. Which of those 2 groups would you like to switch? We'll switch 2 and 3. So we'll put 3 over here, and we'll put 2 over there. And the chlorine is at the top. So now we have 1 and 2 and 3. So now when we look at the order, we circle around that way, and that's going counterclockwise to the left, and this is the S enantiomer, this is the R. Okay? Determine the absolute configuration of the following enantiomer of 2-butanol. Determine priorities. Which of these groups has the highest priority? The hydroxy group. And which one's lowest? The hydrogen. And which one's number 2?
Double carbon.
Yeah, the ethyl. Okay. Is the lowest priority group in a vertical position?
Yes.
It is. It's behind, so we're okay. So now we can just see 1, 2, 3 going around to the left, and so the correct name for this would be S2-butanol. Okay.
Since it's not, if it's not in order, it doesn't matter. It's not, it's 1, 2, 4, 3.
We're not looking at the 4. We put the 4 behind and we look at the other 3.
So we don't even count that. We just want to do 1, 2, 3. That's it.
Yes. But you want to make sure that the 4 is either going up or down so it's behind. Otherwise you're looking at it from the wrong side and you'll end up with the wrong answer.